Hello, welcome to Motion Study in SolidWorks. We'll be looking at simple crank piston mechanism. And we're doing a motion study of the mechanism with a motor speed of 1000. Well, we can change this to 500 RPM, stepping it down a bit, 500 RPM at the crank handle for 3 seconds. We will also investigate the variation of some key parameters such as the piston displacement, velocity and acceleration, reactive force of the connecting rod. We also carry out a dynamic stress simulation of the system to observe the variation of Mrs. stress for the time duration. Now we'll go to SolidWorks environment, and then we have the setup here already. We'll quickly go to our add-ins, and we can get that from our tools bar add-ins, and we'll quickly ensure that the SolidWorks motion and SolidWorks simulation add-ins are checked appropriately. They are checked here. So we'll go to our motion study, and then within our motion study we'll be working with motion analysis, and then we are going to disable disorientation and camera views such that we are able to navigate properly. And within the within the tools available to us, we'll be working from right to left. We'll be moving from gravity down to our motor speed. So we'll select gravity, and I think we are it has given us a right direction for the gravity, which is opposite of the z direction, and we can take that. You see that once any change is effected, we have it recorded in the timeline. We are going to set in our body contacts. We want SolidWorks to identify the contacts between components. Now we'll just create a box to cover the whole mechanism, and we can okay that it has created a solid bodied contact for us right in the browser. Now we'll quickly go and impute our motor speed. It's a rotary motor, and we'll be applying the motor speed right on this edge. We can toggle the direction of that edge this way or this way, clockwise, anti-clockwise. We'll maintain this direction. I will choose an RPM of 500. Now we have all that set up, and then we can run our motion study. I will put that in place, right? And then we'll use this button, calculate button, to actually calculate the motion study if it has not been run before. So we click on that, and we can see our model running for 5 seconds. We are done with running it. We are done with running it. It has run for 5 seconds, but we actually need 3 seconds. So we'll take our key, it's called a key, take it back to 3 seconds, and it will record our study up until the 3rd second. Now we can replay this and see the movement of the different components. Now we have run the study. We would like to observe our key parameters: the displacement, velocity, acceleration and reaction force. You can get those by clicking on the result and plot button. I want to observe the displacement of this point relative to that point right there. And then we are looking at the piston body. So we are going to select the body, and we can observe how this point here varies relatively, or varies with the other point that we selected. And then you can see its variation from a maximum of 42 down to 5, back up to 42, and on and on. Also be trying to observe the velocity of the piston at this point, how it varies within the time duration. And then we can do that by selecting velocity, linear velocity, the z component, and just selecting that edge. Of course, the body is the piston component. Select that, and we get this plot of of that point, the velocity of that point in within that time duration. And we see starting from a zero, obviously, going down to minus 842 millimeter per second, and going back up to 961 millimeter per second, same as 0.961 meters per second. Now we have that. We can also, in the same way, get our acceleration and so many other components, but we'll just go and look at the reaction force of the connecting rod. We have the reaction force, and then we'll be selecting the magnitude of that reaction force. Now, if you hover around here, you can read what it tells you to select. Select one mate stroke simulation element and or one face of part attached to it. So we can select this mate constraint, and the body of investigation will be the, the connecting rod. And then we can select that, and yes, and we can see the variation of the reaction force on that connecting rod against time. And then we can move on to exporting a particular component for stress simulation. And we can do that by clicking this button here, and then it will tell us to add a time step or time range for investigation. And we can take 2 seconds, 0 to 2 seconds. We add such a time, and we also have the ability to change our mesh density. Okay, right now it's not highlighted, probably because we have not selected a component. We'll select this, the connecting rod, and then we can now reduce our mesh density because of simulation time. And then we set that up. We can run our simulation. Would you like to calculate the motion study before running simulation? Well, we have calculated it. We don't need to recalculate it again. So we select no, and our simulation will begin. We observe that our uh, simulation is coming to a close. It's at 100%. It's doing some post processing, and then we'll have our results shortly. Yes, simulation in motion analysis has come to a close, and you can observe the formative stress for the connecting rod. Can we go ahead and close these results? Now we can run our simulation or our motion analysis from the beginning and see how the formative stress changes at different times, time intervals, and then so you can see it's still running, but our simulation is out because we selected 0 to 2 seconds, and then so we can observe at any point here. We can see the stress distribution in the connecting rod, and then for any time at any time instant we can get those values here, and then we can go further to get a deformation plot and even a factor of safety plot. So if we get the factor of safety plot, you will observe that um, you obtain a minimum and maximum factor of safety of the connecting rod, and also have other values within the connecting rod. So at any time instant, you can have those values for you. You also have the deformation plots. You have to, and it tells you the different areas within the connecting rod or around the connecting rod that are highly displaced or less displaced, less deformed at any time instant within 0 to 2 seconds. And then that is then yeah, that will be all for motion study and simulation in motion study. Thank you.